Hi guys, and welcome to the first activity in Year 8 Physical Sciences. In this activity we're going to look at what energy is. Okay, so energy can be defined basically as when work is being done on a system. Here's a definition for you here. Work done on a system. Now let's break that down. Let's sort of try and understand what that actually means. Think about you going to school. You go to school and you may do an 8-hour day. Some of you may do a lot more than that. By the end of the day, how do you feel? Well, you're tired. Now, why are you tired? Well, energy has been used. You have done work. Now, we all say, I'm going to work today. Now, depending on the type of work you do, depends on the amount of energy which is utilized. So there's a direct correlation between energy on one side and the work that's done. If you do a lot of it, use up a lot of energy, you're doing a lot of work. Now, you think about your 8-hour day at school. You may say, well, I don't do a lot there. I sit in class and I sit and think, and I might write with my pen. I might do some computer work, and I might do, but I'm not doing a lot of physical work. No, but over a long period of time, 8 hours or so, that energy mounts up and mounts up and mounts up, and by the end of that day, you've done a huge amount of work. Think about your parents. Some of your parents may be in a very taxing job, something where they have to think. They may be in the office all the time, but when they get home, they're exhausted. They've done the same hour day as you have, but they probably had to think a lot harder. Think about people who do a lot of physical labour. They'll come home, they're exhausted after a full day's work. Now, they may only have worked 8 hours, or they may have only worked 4 hours. But you can work 4 hours and work really, really hard, very, very physical, and you'll be exhausted. It's the same as working an 8-hour day, maybe in an office. So there's a direct correlation between energy and work. Now, the system part of it is where you are actually doing the work. What is the work being done upon? For example, if I take this clicker and I move it up, I've done work. It's not a huge amount of work. I'm not particularly exhausted, but I have done work. This is the system, and it's working against the concept of gravity. So when you think about energy, you've always got to think about the concept of work being done on a system. And as we go through our physics units, you will understand that work has a number of variables that link together, and then by linking these together, you can understand exactly what's happening to the system. But let's have some examples where we can put all this sort of theory into practice. So let's look at this picture that we've got here. We've basically got a foot which is pushing against the accelerator pedal inside of a car. Now you may think, not a lot of work. Well, you'd be right, there isn't a lot of work. But you go driving for 8 hours with your foot continuously on the pedal. Now you are holding that foot in that specific position. Now what that means is that there is energy being utilized in the muscles. Okay, so if we're using energy, we're doing work. After a period of time, you're going to get tired, that's right. Now if the pedal resists really, really strong, as in it's really, really tough to push that pedal down, you're going to have to put more energy in and do more work to push that pedal, which means you're going to tire out faster. Okay, however, if the pedal is very, very slack, very, very easy, won't take a lot of energy to push it down, so as a result, you can do it for a lot longer. So you can see the idea, I hope, of energy being done on work as work on a system. Let's take this girl here. She's working out in the gym. Now we all know if you go to the gym, you can lose weight. Now let's break that down. Weight often is in the form of fat. Fat is a good store of energy. Now when you lift up a weight, a dumbbell, like this girl's doing here, what you're doing is you are going against the force of gravity. The force of gravity wants to pull that weight down. Your muscles are basically using energy to keep it up. So by pulling that weight up, you're going against the force of gravity, so you're doing work. If you put more weight on, gravity is pulling that down a lot harder, which means you've got to work a lot harder to resist it. So again, you're doing work against the system being gravity pulling it down and you pulling it up. Let's look at this picture here. Now in this picture here we've got 4 different rooms all lit with different types of light. Now you may think, where's the energy going on here? Well, the energy and the work that's going on is inside the globes of the lights themselves. Inside those globes generally you've got, if we've got a filament globe, you've got a wire, and in that wire you've got electricity which is flowing. The wire resists the flow of electricity. So here's the resistance, here's the system concept. As the electricity flows through and there's resistance, the energy of the electricity is pushing against the wire itself. Now what happens is the resistance, the actual wire resisting the flow of electricity generates heat. That heat comes off in the form of light, and as a result that light can then fill the room. Because that light can fill the room, and by using different filters we can put different colors in there, but the actual work that's going on is with the electricity flowing through the wire. Quite a difficult concept to try and understand, but again we put the idea that light is a form of energy, and as a result that energy has been as a direct result of work done on another system, the resistance in the wire. The final one we've got here is this chef. This chef is cooking. Now you'd never really think of cooking being a science, but it is. And basically what's happening is you are using the concept of energy. Now let's look at the picture. Now you've got these flames going on, so he's doing some flambe cooking, so he's heating with oil or maybe alcohol or what have you. Now those flames basically is the energy. There is a direct result of the reaction of combustion. Now combustion is where heat causes the cooking oil or the alcohol to burn. Now the heat is then, as it burns, is basically going to be transferring the energy to the food, which will change the food. You must have seen mum or dad putting a steak on the barbecue or in a pan, and the steak basically starts off pink, but as it's cooked through it changes colour. That is due to work being done on that system of the steak. Something is happening between the steak and the cooking surface which is being cooked in. Let's look at another example with respect to a fried egg. You take a fried egg, it starts off clear, but as you do work on that system, it changes colour, goes to that white. Now the more work that's done on the cooking process of that fried egg, the harder it gets. Think about your yolk. You want to make sure that your yolk, in most cases, especially for me, I like to have my yolk quite runny. So I don't want a lot of work being done on my fried egg. Other people might like their yolk incredibly hard. So when you cut it, nothing comes out. So they want more work done on their fried egg. But the work that's being done is the energy of the heat cooking through the actual food. So in all these examples, you can see the concept where we've got work being done, and as a result, the work being done is as a direct relationship with energy. So throughout the rest of this course, what we're going to be looking at is this energy factor. How do we use energy? How do we determine how much energy is used? Useful energy, non-useful energy, and we're going to try and pull it all in together so by the end of the course you totally understand what energy is all about. Okay, well thanks for watching and join me again.